So on our next one, we have this multiplication problem, x squared minus 2x minus 8 over 9x squared minus 16 times 3x squared plus 10x plus 8 over x squared minus 16. And once again, we're just factoring each spot. X minus 4, x plus 2. 3x minus 4, 3x plus 4. 3x plus 4, x plus 2. X minus 4, x plus 4. Okay? So the 3x plus 4's cancel. The x minus 4's cancel. The x plus 2's do not cancel. 3x minus 4, x plus 4. And there's our answer. Here, 10x over x minus 3 plus 2 over x squared minus 9. So here you need to create the common denominator. You don't have it right now. I'm going to start by factoring the bottom here. And what I need to recognize is I have an x minus 3 here, but not an I have an x minus 3 in both spots, but not an x plus 3. So I've got to force the x plus 3 in. So on top, it's 10x squared plus 30x over x plus 3x minus 3 plus 2 over x minus 3x plus 3. Now, once I have the common denominator, I can write that down right away. And you don't need to FOIL it back. I would just leave it. And now we're just adding or subtracting our top. 10x squared plus 30x plus 2. Now, you could factor a 2 out of that and be left with 5x squared plus 15x plus 1, which can't be factored. I'm just going to let you leave it like this. And that's my answer. Synthetic division. When you're given the x value, which was negative 3 here, you don't have to change the sign. You're not dividing by an x plus 3 and you change the sign. They're telling you the x is negative 3 with that f of negative 3. So 2, negative 4, 3, 1, negative 6, and there's no spot to skip. From negative 6, we get negative 10. Now we get 30, and that's 33. We get negative 99, that's negative 98. Negative 98 times negative 3 is 294. And the remainder is 288. And that's your answer. Okay. So if I were to plug negative 3 in for x, I would have gotten 288. Just easier to do it through synthetic division. Now, here with the normal curve, standard distribution, we're at 75 with a deviation of 3. So 72, 69. And I always like to set up the chart first. 78, 81, 84. 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and then 0.15. Now on this one, okay, so the percentage between 70 and 80, we're going to do second bars, which puts me at distribution. Hit 2, my lower is 70. My upper is 80 with an average of 75 and a standard deviation of 3. And that percentage, about 90.4% of the students will come between 70 and 80. And that does make sense if you look at the numbers up there. The lowest 5 percentile means an area of 0.05. So here we go, second function vars. We get 3 and my area is 0.05. 75 is my median, my mean. 3 is my standard deviation. 70.06 would be the 5th percentile score. And the top 10%, which means top 10%, which is 0.9 now. I go second function vars 3.9, same area, same median. I'm sorry, same mean 75, same standard deviation of 3, and 78.84 would be my score. And that's how you do the statistic questions on this section. Now we have percent. We have a car that's depreciating. The equation is 18,000. The car depreciates at a rate of 2.5%. So 100 minus 2.5, 90.975. So that percentage is going to be less than 1. 100% minus 2.5% is 97.5%. So I move that decimal point. And we want to know what it is going to be over 7 years. Okay. The equation that models the price of the car, the years would be X. So this would be the equation. When I want an answer after 7 years, now I'm going to put 7 in for X. So 0.975 raised to the 7th power gives me something like 0.83. I'm not going to round it because I have a calculator. I'm just going to multiply it by 18,000. And I'm going to have a car that's worth $15,076.65 in the end. Number 6, we have 16 to the 3x equals 64 to the x plus 2. That's where I need to get common bases. 4 squared to the 3x, 4 cubed to the x plus 2. 4 to the 6x equals 4 to the 3x plus 6. And now I'm setting my exponents equal. Oops, plus 2 plus 6, excuse me. We get 3x equals 6, and my x equals 2. And finally, and I am going to use my graphing calculator for this, 2x cubed plus 9x squared plus 12x plus 2. I would probably use my decimals calculator, to be honest with you. The degree of this problem, though, is 3. The leading coefficient is 2. Okay, so we're going to put the equation in our decimals calculator. 2x cubed plus 9x squared plus 12x plus 2. And you notice there's only one spot it crosses the x-axis at. So that means there's going to be one real zero. There would be 3 zeros, but there's only one real zero where it crosses the x-axis. The relative maximum is right here at 2, -2, and the relative minimum is right here at -1, -3. So -2, -2, -1, -3. So rel max, -2, -2, relative min, -1, -3. And finally, the ending behavior, you're going to read right off of the graph. As x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity.